Good morning, children. Welcome to online classes DU Nalgonda. My name is K. Narasimhachari, School Assistant Physical Science, JDPHS, Pulimamidi. In the previous classes, we learnt about human eye, colorful world in 10th class Physical Science. In the last classes, we discussed about distance of distinct vision, angle of vision, and accommodation of eye lens. From the accommodation of eye lens, we found that maximum focal length is 2.5 centimeters and minimum focal length is 2.7 centimeters. Sometimes eye lens lose its ability for accommodation. In such conditions, the person cannot see the objects clearly. It is called defect of vision, and these defects are divided into three kinds. They are: one is myopia, second one hypermetropia, and third is presbyopia. Children, we discuss about the defect myopia in this class. Sometimes some people cannot see objects at long distances clearly, but nearby objects clearly. This kind of defect of vision is known as myopia. We also call this defect as nearsightedness, because people suffering from myopia can see the objects near the eye but cannot see the objects at long distances. In this case, the focal length is less than 2.5 centimeters. In the case of myopia people, the rays coming from distant objects after refraction through the lens meet and form an image before retina. That is why the people cannot see the object at long distances. Now, healthy persons or healthy people can see the objects at more than 25 centimeters distance very clearly, whereas people suffering from myopia cannot see the objects clearly, because as I said you previously that the rays coming from the object meet before retina to form the image. I showed you here two figures. From these figures, you can clearly understand how myopia is possible. See the figure A. Object is at infinity. Rays coming from long distances, when object is kept at infinite distance, are falling on the eye lens and meeting before retina to form the image. Whereas here also in the case B, object, I showed here the point O. Imagine this is object. Rays coming from object still forming an image on the before the retina. So we further discuss about these two conditions once again, that people suffering from myopia can see object before least distance of distinct vision and up to a point. For example, people suffering from myopia can see object at least distance and anywhere up to a point M. People can see an image of an object. People can see image of an object at least distance of distinct vision and up to a certain extent, that is here the point M. Till M, if an object is kept, the person suffering from myopia can see the image of the object clearly. So the point of maximum distance at which the object can be seen is known as far point. So from least distance of distinct vision and up to a far point, the person can see an object clearly. Whereas object is at infinite distance or object is beyond far point, the object cannot be seen by the person suffering from myopia. Now, we get a doubt. Should we leave the people suffering from myopia as it is, or should we invent a method to find out, to correct the defect? Yes, we can correct the defect with the help of lenses. But what is the method of identifying the lens? Here we found from the above cases that when an object is at M, that is a far point, or at L, the least distance of distinct vision, or between M and L, we can see the object clearly. This is one point. And second point is, when an object is beyond M, it cannot be seen by the person suffering from myopia. So taking these 2 points into account, we can find a solution to correct the myopia. That is, if we are able to bring the image of the object kept beyond M, between M and L, using a lens, we can find the image on the retina. That is, I am telling you again that when an object is kept at long distance, say infinity distance, we have to try to bring the image of that object to fall between M and L, so that the image of the object is seen clearly. This is a correction of myopia. And the lens we use to correct this eye defect is concave lens. When we try to bring the image of the object at long distance between M and L, the image acts as an object, and the rays coming from the image to fall on eye lens after refraction form an image again on the retina, so that the object is clearly seen. So this is the correction of myopia. For that purpose, we use the lens concave lens. Concave lens is a correct lens that we use for correcting the myopia. Now, how to find out focal length of the lens we use in correcting the myopia? For this purpose, we select a biconcave lens to form an image kept at long distance at the far point. We first try to find out the image of the object at long distance at far point, and then we have an image on the retina. Now we consider the distance, object distance is equal to minus infinity, and image distance is equal to minus d, and consider focal length. Applying these three values in lens formula, 1 by f equal to 1 by minus d minus 1 by minus infinity. 1 by f is equal to 1 by minus d minus 0, and 1 by f is equal to 1 by minus d, therefore f is equal to minus d. It is noticed that focal length of the eye lens we use in correcting myopia is found to be negative. This negative sign refers to concave lens. It explains that concave lens is a lens used in correcting the myopia, so that myopia is corrected. So children, this is the way how the eye vision or the defect in vision comes in the form of myopia and the correction of myopia. We learn about hypermetropia in the next class. Thank you. Good morning, children. Welcome to online classes DEO Nalgonda. My name is K. Narasimhachari, Physical Science School Assistant, ZPHS, Pulimamidi. Today, we discuss about one of the eye defects called hypermetropia in the lesson Human Eye and Colourful World in class 10. Children, we have learned in the last class about the myopia, the formation of myopia and the correction of myopia. Now, we learn about hypermetropia. Some people cannot see the objects at short distances, but can see the objects kept at long distances clearly. This kind of eye vision is known as hypermetropia. We also call this hypermetropia as farsightedness. People suffering from hypermetropia have the focal length, minimum focal length of their lens greater than 2.27 centimeters. And in such cases, the rays coming from the object kept in front of the eye, after refraction through the eye lens, meet at a point outside the retina to form image. That is, image is formed outside the retina. Now, if object is at a point, for example, in the diagrams, if object is kept at a point H, which is beyond least distance of distinct vision, the person suffering from hypermetropia can see it clearly. That is, the image is clearly formed on retina. If object is at a point H or beyond point H, the object is observed by the eye on forming its image on the retina. And if an object is kept between point H and point L, the person cannot see the image of the object, because in the figure 2, we call H as near point, that is a point of least distance from which the image of the object is appeared or seen by the lens, or image of the object is formed on the retina. So, when object is at a near point, we call this point as near point. At near point or beyond near point, we can see the image of the object on the retina. Now, as we understand that people suffering from hypermetropia, the object when kept between near point and least distance of distinct vision L is not seen, or image is not formed in the retina. We have to correct this defect using a suitable lens, and we decide a lens, and the lens is called biconvex lens. As we know that object between H and L cannot be seen by the lens, we need to do an activity to correct this eye defect by placing a lens in front of eye in such a way that an object when kept between H and L form an image beyond H, so that the image formed beyond H act as an object to the eye lens and its image is again formed on the retina. That is, the hypermetropia is corrected in such a way that by taking a suitable lens to form the image of object kept between H and L beyond H, thereby the hypermetropia is corrected. Now, how to find out the focal length of the biconvex lens? To find the focal length of the convex lens, we place an object at L, that is the least distance of distinct vision. That is why we take it, the object distance is taken as minus 25 centimeters, because the object is taken at L. As we already learnt about L, that L is the least distance of distinct vision and the distance is 25 centimeters. We consider U as the objective distance, which is equal to minus 25 centimeters. Again, V, we know that V is the image distance. Image distance is not explained in advance, therefore we take it as minus D. And taking these two values in lens formula, 1 by F is equal to 1 by V minus 1 by U, 1 by F equal to 1 by minus D minus 1 by minus 25 gives 1 by minus D plus 1 by 25. Again, 1 by F equal to minus 25D, 25 minus D, and further written as 1 by F is equal to D minus 25 by 25D. For changing minus symbol, we rearrange the values. Again, taking reciprocal of the equation, we have F is equal to 25D by D minus 25. Children, you observe that denominator is D minus 25, in which D must be greater than 25 for becoming F value positive. That is why we say that D is greater than 25. With that, F becomes positive. So becoming F positive in the sense, the lens we are using in correcting the defect is convex lens. F positive F refer to convex lens. Right. After knowing the hypermetropia defect and as well as the correction of hypermetropia, we have another defect of vision that people face is presbyopia. Let us see what is presbyopia. Presbyopia is a defect of vision in which the accommodation of eye lens decreases. The people suffering from presbyopia, the near point recedes away so that the objects kept in front of eyes cannot be seen distinctly and comfortably. People suffering from presbyopia. So this comes on increasing age, that is, on aging, the people getting more and more age will face the defect of vision called presbyopia. Even people suffering from people whose age is more and more will also suffer sometimes both hypermetropia and myopia also. So coming to the points, presbyopia, to correct the presbyopia, we need to select a suitable lens called bifocal lens. In the case of correction of presbyopia, we use bifocal lens, which consists of two parts. The upper part is concave lens and the lower part of the lens is convex lens. That is, to correct this eyesight, the preparators, the spectacle shop people prepare a lens containing both the lenses of concave lens as well as convex lens. Right. In case you might appear the people going to the eye specialist, eye doctor, saying that their vision has been decreased or they are not able to see the objects clearly. When people consult the doctor gets check the eyes whether what the kind of defect the eye has and recommend a suitable lens that suits the eye vision. That is, by writing the information related to the eye defect on a prescription. If you go through the prescription, you notice that the information belonging to the eye lens is printed on the prescription such that it is in the form of power of lens. Generally, doctors prescribe the lenses in terms of power of lens. What is power of lens? Power of lens is the degree of convergence or divergence of light rays that the lens achieved is expressed in terms of power of lens. Power of lens is related or concerned with the focal length of the lens. Power of lens is the reciprocal of focal length. Power of lens is reciprocal of focal length expressed in meters. We also express this power of lens in centimeters, taking power of lens is equal to 100 by f and must write the units beside f, centimeters. So, this is expressed in D, power is expressed in capital D. D in the sense diopter, D is called diopter. D is called diopter. When you consult the doctor, they write down D with some number, for example 2D, 2 diopters. The person requires the lens concerned to 2 diopters. As such, power is expressed. Now, let us go through one example related to this power of lens so that we understand how diopter is related with focal length. For example, when you go to an eye specialist and he recommends you 2 diopter lens, that is said you are recommended to wear power 2 lens. Power 2 lens means P is equal to 2. As we know that P is equal to 100 by f centimeters, 2 equal to 100 by f centimeters. Now f centimeters is expressed in 100 by 2, that is f is equal to 50 centimeters. That is, as you have been recommended by doctor to wear 2D lens, it is said the lens is a lens of 50 centimeters focal length. So this is a way how the defects of vision corrected using the suitable lens. You go through the textbook once again and read clearly. If you have any doubt, you consult your concerned teacher, your school teacher, and get the doubts clarified. Thank you. Good morning, children. Welcome to online classes, DEO, Nalgonda. I am K. Narsimhachari, School Assistant to Physical Science, JDPHS, Pulimamidi. Children, today we are discussing about human eye, colorful world, the remaining parts of the previous videos. Now, we recall some important points that have already reviewed in the last videos. Among them, the first point is distance of least distinct vision. Distance of least distinct vision of a healthy eye is 25 centimeters, and it varies, sometimes increase and sometimes decrease depending on the age. Next, the angle of vision, that is to view an object completely kept before an eye, is 60 degrees. Later, we also discussed about the accommodation of eye lens. Accommodation of eye lens is adjustment of focal length by eye lens with the help of ciliary muscles. Ciliary muscles attached to eye lens change the focal length of the eye lens. Now, in the last videos, we learned that maximum focal length of the eye lens is 2.5 centimeters and minimum focal length of the eye lens is 2.27 centimeters. For a healthy eye, an object kept before 25 centimeters or from 25 centimeter onwards, it is clearly visible to the eye. If the eye lens cannot accommodate itself or cannot change its focal length due to loss of ability of taking strain, there will be problems arise, and there are 3 defects of vision described in the last 3 videos. They are: one is myopia, second is hypermetropia, third is presbyopia. We call this myopia as short-sightedness. That is, in the case of people suffering from myopia, they can see the objects closer to the eyes but not the objects at long distances. Let us draw a diagram related to myopia. This is the eye lens, and L, the least distance of distinct vision, it is always 25 centimeters. And in the case of myopia, when object is at longer distance, for example at infinity, object is at infinity, the person suffering from myopia cannot see the object clearly. That is, the rays coming from the object after refraction through the lens form an image before retina. In the case of infinity, the maximum focal length is found to be 2.5 centimeters, and if object is at L, focal length is 2.27 centimeters. Now, persons suffering from myopia can see object at L, and object is at this point, and object goes forward to a certain extent. Image of the object is clearly formed on the retina, and at certain stage, at this stage, after this, at some stage, up to some stage, the object is appear to the eye, and at this stage, the object, when object kept at this stage, the image of the object is not formed on the retina. When object is at this point, and object is at this point, and object is at this point, this point, this point, and at all these points, the object is clearly visible to the eye, and this continues up to a point. The observation of image of the object is continued to this point, and this point is known as far point. Far point. After the far point, if object is kept anywhere in the region till to infinity, image of the object cannot be seen by the eye. The image of the object kept in this region is not formed on the retina. This is called the eye defect myopia. Now, what is the remedy for this defect? How to correct the myopia? To correct myopia, we recall 2 points. One is object kept between M and L. Between M and L is clearly visible to the eye, and object kept beyond M is not visible to the eye. That is why, taking these 2 points into consideration, we try to bring the image of an object kept in this region. That is, if an object is kept beyond M, as it is not appearing to the eye, or as the image of the object is not forming on the retina, we try to bring the image of object kept in the region to come between M and L. The image of this object between M and L then act as object to the eye lens, and its image is formed on the retina. That is, we are trying to bring the image of the object kept beyond M between M and L, so that it acts as an object to the eye lens and form an image on the retina. Next, coming to hypermetropia. Hypermetropia is known as far-sightedness. Far-sightedness means the people can see the objects at distance, more distance, at longer distances, but cannot see the nearby objects. For example, drawing the corresponding diagram to the eye defect, least distance of distinct vision. People suffering from hypermetropia can see the objects from longer distances. For example, object is at infinity. The image of the object is formed on the retina. As such, they can see this object and taking the point continuously forward to the eye. All these places, object kept at all these places, the image of the object is formed on the retina. Up to this point, the image is formed on the retina. And after the point, if you take the object towards L after this point, the object is not observed by the eye, that is, the image of the object is not formed on the retina. So therefore, this point is called near point. Near point. Distance, the point of least distance at which the image of the object is formed on the retina is known as near point. So, from infinity to near point, the image of the object is formed on the retina, and between H and L, if an object is kept between H and L, it is not found or its image is not seen on the retina. So, now how to correct this hypermetropia? To correct this hypermetropia, we use a lens to get the image of object between H and L beyond H, because children, you understand clearly that we are able to see the object kept in this region very clearly, whereas the object in this region is not in the hypermetropia people. So what we do is we try to bring the image of this object, image of the object in this region to come in this region. The image that comes in the region act as object to the eye lens, and its image is formed on the retina. And in the case of myopia also, we used a lens to get the image of the object between image of the object beyond M to come between M and L, and the lens is concave lens, whereas in the case of hypermetropia we use convex lens. And in the case of myopia, see an important point that we are not able to see the objects in the region beyond M, and we can see the objects up to a point M. Now, speaking this point in terms of focal length, it is from 2.5 centimeters, going from 2.5 centimeters to 2.2 centimeters, this point is towards 2.0 centimeters and after 2.5 centimeters. That is why what we call is the maximum focal length of the eye lens regarding myopia people is less than 2.5 centimeters, and as here the focal length is 2.5 centimeters and focal length is 2.27 centimeters, and this point is closer to 2.2 centimeters and towards 2.5 centimeters. We say that minimum focal length of the people suffering from hypermetropia is greater than 2.27 centimeters. So in this way, we correct myopia using a biconcave lens and hypermetropia using a biconvex lens, so that the correctness is adjusted. The eye defects are adjusted. Now, speaking about presbyopia, presbyopia is a defect that comes through the age. As age increases, this kind of defect arises. So, to correct the presbyopia, we use a bifocal lens containing both concave lens and convex lens. Top portion of the lens is concave lens and lower portion of the lens is convex lens, so that presbyopia is adjusted. This is the way how eye defects appear and also corrected using the relevant lenses. That's all for today, children. Have a nice day. Thank you.